In this video, we're going to connect the graph of a function to its function notation. So we're going to practice reading points off this graph and writing them as function notation and vice versa. So I have given the rule here for the function. This is a quadratic function. It's a polynomial of degree 2. I can see that my graph is a U-shaped graph. It's a parabola. It's pointing up. And if I really wanted to, I could get every single point on this graph by inputting specific x values into this function, following this quadratic rule, and seeing what the output is. But I don't want to do that. I just want to read the graph. But we could plot these points algebraically. Let's actually read this graph here and find some important points on this graph. So let's start here. Let's start, where is f of x equal to 0? What is this notation asking me to do? So when I read this notation, I'm being asked what values can I input into the function so that the output of the function is 0. Well, the output corresponds to the height of the graph, And that's going to be located here on the y-axis. So I can see that if I'm above my x-axis, my y values or my outputs are positive. And if I'm below the x-axis, then I have negative outputs. But if I'm right on the x-axis, if I'm right here on this x-axis, the height of the graph there is 0. So where does my function here, remember this parabola is the graph of the function. It's every single solution to the function plotted visually for me to see here. So where's the height 0? Where does it hit the x-axis? Well, at 2 points. It hits it here when x equals -3. My parabola crosses the x-axis there. And again, over here, when x is a positive 1. When x is a positive 1. So another way to interpret this notation, another way to rewrite what it's asking you to do here is it's asking you to find the x-intercepts, because the x-intercepts right there on the x-axis, that's where the height of the graph is, the point is 0. So we're just finding our x-intercept. So I can see if I put -3 into my function, the output is 0, the height of that point is 0. And again, if I put a 1 into my function, the height of the graph is 0. Okay, now let's focus in here on these positive outputs. So when the parabola is above the x-axis, the outputs are positive. Let's just check some points there to see what I mean. Let's input x equals -4 into the function. Okay, if I input x equals -4 into the function, I come up until I hit the graph of the parabola, boom, right there. And I go over and see that the height is a +5 there. So the way I would write that notation is I would say f of -4, if I put -4 into the function, if I input that in the function, and I follow the rule, it's going to output a height of 5. That's a positive output. Same thing over here if we input a +2. If I input +2, I'm going to go up, up, up till I hit the parabola, boom, right there. Oh, that height is also 5. Okay, so if I input a 2 into my function, the height of that graph is also 5, which is a positive number. And the same would go if I input, for example, 1.5. 1.5. If I put 1.5 in the function, I don't know, my height looks right there-ish. That's a little bit murkier. So what I could actually do is I could actually put 1.5 into the function, and since I'm given the rule, I could actually go like calculate the exact height of that point, but the output I get should be positive because it's above the x-axis. So the way we generalize that is we say this. We say that all of these values, here, everywhere, all of the outputs above the x-axis, that's where f of x is going to be greater than 0. It's not going to be greater than or equal to 0, okay, because we're just looking strictly above the x-axis. At the x-axis, it actually equals 0, right? So if I want to be above the x-axis, then I want to be strictly greater than 0. So when you read this notation, remember, f of x, that's an output. That's the output we get when we input an x value into the function. So when you see f of x, it's automatically describing outputs. It's automatically describing the heights of the graph. So if f of x, if that output is greater than 0, we interpret that as it being above the x-axis, or you can interpret that as having a positive output from your function value. And likewise, if we're below the x-axis, so if we're down here in this region, okay, we would write that like this. We would say in this region, where we're below the x-axis, our function notation would look like this. We'd say f of x, that's the output we get if we put x into the function and follow the rule. That's going to be strictly less than 0. Okay, so, and those are going to be your negative outputs. Okay, what else might be an important point on this graph? Oh, hey, how about this one? How about, since this happens to be a parabola here, how about this vertex? The vertex of the parabola, that's where it changes direction. My function was decreasing, the heights were going down, and then I hit that vertex. And after the vertex, my function started increasing again. The heights of the point started going up after that point. So what is that vertex there? Well, let's see, that is happening at the ordered pair, what? That would be a -1, -4. So to write that as function notation, I'd say if I put -1 into the function, the height of the graph is -4. See how that's a negative output? It's below the x-axis. Okay, so let's practice writing some of this out here. So if I wanted to know, okay, wait, let's start up here. Okay, if I wanted to know for what values of x is f of x greater than 0? For what values of x is f of x greater than 0? Again, that's the regions where the outputs are above the x-axis. That's where my outputs are greater than 0, where they're positive. So I would answer that by saying, okay, where is that happening? Well, any of these x values from -infinity up until I hit -3, I'm getting outputs that are above the x-axis. The output's going up. If I plug in any of those numbers into my function, the outputs are going to be above the x-axis. Okay, so I would represent that in interval notation by saying -infinity, -3. We never include infinity. That's always a parentheses. And I don't want to put a bracket there. A bracket would mean I could equal 0, because at -3, if I put -3 into my function, I get 0 out, right? So if I just want strictly greater than, I'm going to use a parentheses there to show we're not including -3. And then I need to hop over, so I'm going to do a union, and I'm going to pick up here at x equals 1. If I plug in any of these inputs all the way to positive infinity, the heights of the graph are going to be positive. So I'm going to pick back up at +1, not included. If x equals 1, the height is 0, so I don't want to include that, all the way to positive infinity. So that's the interval notation to describe where the outputs are positive, where they're above the x-axis, where they're greater than 0. And just heads up, we're always describing x values there, because f of x greater than 0 is always already telling you what's happening to the outputs. We want to know what inputs cause that to happen. So we write that interval notation to describe the x values. Okay, we've already answered this next one. For what values of x is the function exactly equal to 0? That would be only 2 values. It only happens when x is -3, and again, when x is equal to 1. So there's not an interval for that. It's 2 specific values. And then for what values of x is the function output less than 0? Where is it negative? Okay, remember that was here. And that's happening from -3, not included, all the way to +1, not included. Okay, now let's take a look at some of the examples from that prerequisite quick check about reading some function notation. So if you haven't tried these yet, pause the video, give these a try, and then check yourself with the video. Okay, so let's see how you did. For this set of problems, our function is being represented graphically. We are not given the rule to this function, so we can't get these answers algebraically. We have to read directly from the graph. This happens to be an absolute value function. It's a V-shaped graph opening down. You don't need to know any of that, but Let's just read the graph to find these values. Okay, what is 2 asking us to find? It's asking us to find f of -1. So it's asking us to find the output we get. Okay, so it's asking us to find what is the output we get if we input a -1 into the function. So if x is a -1, what is the corresponding output? So let's locate -1 here on the graph right here. That's where x is equal to -1. And if I go up and hit my graph, remember that graph is a visual representation of all the solutions to the function, all the inputs and the related outputs. So if the input is -1, the height of the graph is 2. So I would say that the output is 2, +2. And we can represent that as the ordered pair -1, 2, or -1, f of -1, because the output we get when we put -1 into the function is a height of 2. So those are interchangeable. Anywhere I see an f of -1, I can erase it and replace it with the output 2. Okay, now what about this next question? What is question 3 asking us? Well, in this one, we know the output. We know the output is a +4. It's asking us what would we have to input into this function to create an output of 4. And remember, the output is the height of the graph, right? So the height of the graph. So let's go locate the height being 4. So here's where the height is 4. Okay, and where does the graph reach that height? Only at 1 point. Sometimes it can be more than 1 point. Okay, so only at 1 point right there, and that I backtracked down. That's happening at an input of x equals -2. So I would write my answer like this. I would say either x equals -2, or I could show if I put a -2 in the function, I get an output or a height of 4. And just to piggyback on that real quick, what if I had asked f of x, where's f of x equal to +2? Where's f of x equal to +2? So here's +2, a height, an output, a height of the graph of 2. And if I look over there, see how that's happening in 2 locations? So there would be 2 inputs that create a height of 2. Okay, so for this answer, I would say at x equals -3 and at x equals -1. There's 2 different inputs that create that height. Okay, what is 4 describing? 4 is asking again for inputs. What are we going to input into the function so that the height of the graph, so that the output is 0? Remember, that's another way to describe your x-intercepts. And that's because a height of 0 is right along that x-axis. So where does that happen? It happens in 2 locations. I have an x-intercept here when x is equal to -4. So if I put -4 into my function, I get a height of 0. And I have another x-intercept right here when x is 0. So if I put a 0, if I input a 0 into my function, I get a height of 0. So there's going to be 2 x values where that happens. At -4 and at x equals 0. Okay, now this last one's a doozy. This is actually function composition. So what in the world is happening here? So I have a -3, and I'm plugging -3 into my function. Remember, f of -3 is an output. And when I get that output, okay, so when I get this output here, whatever this is, some kind of output, whatever that output is, it's going to become the input of the function again. Okay, we're plugging the output of a function into another function, in this case, the same function. So what in the world does this look like? Okay, let's just take a look at this. Okay, you always start with the innermost parentheses and work out. So if I plug -3 into my function, what do we get? Let's go look at the graph. If I put -3 into the function. Okay, here's x equals -3. I come up, I locate the related output. The related output is a 2. So I can replace f of -3 with the number 2. If I put -3 into the function, it's an output of 2. but that output is getting plugged back into the function again, okay? So now I'm going to locate +2 on my x-axis. It's my input now. Then I'll go down and find the related output down here. That's an output of -4. So overall, when I compose those functions, I get -4. So f of -3, overall, the final output is going to be -4. Now, if you need more review on that, just go to YouTube and search composite functions. You can also look back through your old notes from your previous math class, college algebra, or business math, or you can come to my office hours and get help, or get help from one of our instructional associates or from the Learning Lab. So make sure that you're really comfortable reading function notation, inputs, outputs, locating them on a graph, changing function notation to an ordered pair back and forth. And if you need help, we're here to help you.